In this video, we will be discussing how to use everything we've learned this unit to determine the various proofs and whether or not they are hypotenuse leg, side side side, side angle side angle, or angle angle side congruency. Now, this first page of your notes gives some of the key things that we have talked about, some of the key reasons for why certain things are congruent. So our first two guys here, where we talk about midpoint and bisector, are talking about how that the lines could be congruent because they are split by either a point, like the midpoint, or by a line or line segment or array, like the bisector here, CD. Now, I know we've talked a lot about bisector being strictly for angles, but we can also have a bisector for a side. So if you see the word bisector, okay, know that it's going to split something into two congruent pieces, whether that be a segment or, like this guy down here, an angle. Okay, so you really got to pay attention to whether or not it's talking about a segment being bisected, to where we have a segment bisector, or it's talking about an angle bisector, where it's splitting an angle. Notice the difference. This says that CD is a bisector of the segment AB, whereas it says ray DJE is a bisector of the angle CDF. So make sure you're paying attention to that. I really want to hammer that in. There's one more guy that we need to add to our segment reasons, and that's our friend the reflexive. So let's add the reflexive, where I have something like this, where the two triangles share. And we can say that segment AB is congruent to segment AB by reflexive property. And so those three are kind of our main side reasons that we're going to use in order to figure out our sides. And then we have our angle guys. So we have, like we talked about just now, the definition of a bisector. So this is definition of a bisector is going to be our reason. Same here, definition of bisector. Okay, midpoint would be definition of midpoint. So those are our reasons that we will use in our proofs. But we also have perpendicular. So definition of perpendicular would be the reason. And that allows us to say that if two lines intersect, then that right angles are formed at that intersection of the two lines. So we have A, B, and CD intersecting, and we have 1, 2, 3, 4 right angles all formed there. Now, down at the bottom are more ways for us to find angles. If you see the things in the white, so the white reasons here means that we have to have parallel lines. Okay? Our lines have to be parallel, and in this case specifically, A is parallel to B. Okay? Remember, this means parallel. Okay? And our dark reasons occur all the time. Okay, when two lines intersect. So our dark reasons are those vertical angles and our linear pairs, which occur whenever two lines intersect. And our parallel ones are corresponding alt interior, alt exterior, consecutive interior, and consecutive exterior. But we don't really care about consecutive interior or exterior as much when we're talking congruency, because they're not congruent. They add up to 180. So these guys we don't really use that often. But we do use alt interior, which we saw a lot in our notes, and we're going to use corresponding a lot. So when we're talking about angles, these two, alt interior and corresponding, are some of our primary parallel angles that we're going to be looking for. So, with that being said, let's do some proofs. Okay. We have example 1 here. We're given that segment AD is congruent to segment AB, and segment DC is congruent to segment BC. And we're trying to prove that triangle ADC is congruent to triangle ABC. Now, some things you need to know is that there's going to be extra boxes because, quite frankly, we're at a point where we are wanting you to figure it out, and there may be extra boxes. You may use all the boxes, some of the boxes, or need more boxes depending on how you do it. But the biggest thing that I have noticed from seeing y'all's work so far is we're not labeling the picture with the information we're given or with the information that we said we can use. And that's causing us to super struggle at seeing whether or not it's SSS, SAS, HL, AAS, or ASA. So, let's do example 1. Let's label our picture and see what happens. So, segment AD is congruent to segment AB. So, this segment right here is congruent to this segment right there. Okay? DC is congruent to BC. So, right now I have two sides. So, things that we can get rid of. If I were to say HL, SAS, SSS, AAS, or ASA, just from the given and looking at the picture, I see no information about a right triangle, so HL's gone. I have two sides, so I could have SAS. I have two sides, so I could have SSS. I do not have two angles, and I do not have two angles. So AAS and ASA are gone, leaving me with two possible choices. So now I go through my list of reasons on the previous page, and we see, all right, I have no information about angles whatsoever, so I can get rid of SAS, but I do have a side shared right here at AC, so AC is reflexive. And now that I have all of that and my picture is labeled, I can see that SSS is indeed the guy that we're going to use to say the two triangles are congruent. So we go to our given and we can write our given. So I have segment AD is congruent to segment AB, and I have segment DC is congruent to segment BC. So there are my givens. Okay? And now I need my third side. So I have one side, two side, and since I said SSS, I need a third side, so I can say that segment AC is congruent to segment AC because of the reflexive property. And now I'm all done because I have side, 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 so then I can say that triangle ADC is congruent to triangle ABC by the SSS congruency. And notice I have an extra box. So that extra box is there to allow you to write your givens on separate lines if you want to, or on one line like we did just now. Example 2. So once again, I'm going to read all my givens in my proofs so I know what I'm doing, and then I'm going to label the picture and then fill in the proof. So AC bisects DAB. So that angle 1 is congruent to angle 2. So remember, a bisector splits, in this case, the angle into two congruent pieces. And so we're splitting DAB. So this angle right here is being bisected. And then it told me that angle 1 is congruent to angle 2. So notice that it's not this angle that's splitting, but rather the angles around angle A. Okay? So right now, if I were to write out SSS, SAS, HL, ASA, and AAS, and I were to go through and see which ones I can eliminate, well, the bisects allows me to split this angle into two congruent pieces, or the bisector. So that's an angle. And then it told me angle 1 is congruent to angle 2, so that's an angle. So I have two angles, which means SSS is gone, SAS is gone. None of the angles are right angles, so HL is gone. So I'm down to ASA, or angle, angle, side. Well, I already have the two angles, so I need to go through and find my side. And it appears once again that the two triangles are sharing a side. So AC would be reflexive. So I could say AC equals reflexive. And if we look, I have angle, side, angle. So my side is sandwiched between my two angles. So AS is out, and angle, side, angle is my congruency. So now I've labeled my picture. I've determined all of my pieces, so I can plug stuff in. I have segment AC bisects angle DAB. And this time I'm going to split up my givens, and I'm going to say angle 1 is congruent to angle 2. And both of those were given to me. I'm then going to say that angle DAC, so DAC, is congruent to angle BAC. And the reason for that is definition of a bisector. Because again, a bisector splits the angle, the side or the angle, into two congruent pieces. In this case, it's the angle, so it splits it. I need to remember, if there's two angles at a point, then I use three letters. If there's only one angle at the point, then I can use one. But if there's multiple angles, I need to use three letters. So DAC, angle DAC, is congruent to angle BAC by definition of a bisector. Now we need the next part, which was segment AC is congruent to segment AC by the reflexive property. And then we have triangle ABC is congruent to triangle ADC by ASA, or angle, side, angle. Okay? Last one. All right, example 3 looks a bit of a doozy. We have if segment IF is perpendicular, don't forget that means perpendicular, to HG, segment HG, and segment FI bisects angle HIG. So once again, bisects means that we're going to split the side slash angle into two congruent pieces. Okay? So, and we're trying to prove that the two triangles, triangle HFI is congruent to triangle GFI. So here we go. Let's take care of this. So, given that segment IF is perpendicular to segment HG, so I have segment IF is perpendicular to HG, that means angle 3 here and angle 4 are congruent because they are right angles. So we'll see what we need to say about that. We may just need to mention that they're right angles, or we may need to mention that they are congruent. We also know that segment FI bisects the angle HIG. So here at angle 1 and angle 2, we have congruent angles due to the bisector. All right, so we're cooking now. So notice I have an angle, and I have another angle here. So if we were looking here, I could have SSS, SAS, HL, AAS, or ASA. Now, we have the potential for HL because I do have a right angle due to the perpendicular. I have no sides, though, as of right now. So SSS and SAS are gone. And I have two angles, so I could have one of these three. Now, in order to have hypotenuse leg, I have to have primarily the hypotenuse. So if I don't have the hypotenuse, I can't use hypotenuse leg. And the hypotenuse is across from the 90 degrees. And if I look here, I wasn't given anything about these sides. I have no idea what these sides are, so I don't know if the hypotenuses are congruent. So HL is gone as well, which means that I'm going to have to say that these two angles, angle 3 and angle 4, not only are right angles, but that they're also congruent, like we had to do in our 5.4 practice. So here we go. We're going to do our givens. So I had segment IF. Oh, sorry. Both of these have two angles, which means that I need to find the side. And if we see a side that is being shared again. So segment IF is congruent to segment IF because of reflexive again. So we have that reflexive property once again. Okay? And so now we see that we have angle, side, angle, which means AAS is out, and we have ASA yet again. Okay? So let's get our givens written. So we have segment IF is perpendicular to segment HG, and we have segment FI bisects angle HIG. Those were our givens. Next up, we can say that angle 1 is congruent to angle 2. And I don't have to use the letters because they gave me the numbers for the angles, so I can use the numbers to name the angles. So angle 1 is congruent to angle 2 by definition of a bisector. So there's one of my angles of ASA. I can then say that angle 3 is and angle 4 are right angles because of definition of perpendicular. Okay? Then I can say angle 3 is congruent to angle 4 because all right angles are congruent. Okay? And so now I have two angles, so I need my side now. And my side is going to be segment IF is congruent to segment IF because of the reflexive property. Which means that the two triangles, triangle HFI, is congruent to triangle GFI. Sorry, my G got messed up. GFI by ASA. And notice we have an extra box. Again, we have an extra box because we could have split our givens into two boxes, but I didn't feel like it this time. And that is how we use everything that we've learned through this unit to do these proofs. So, really use that reference page that we talked about at the beginning of this video in order to go through your process and say, hey, okay, they're sharing a side, boom, reflexive. Or, hey, there's a midpoint, so definition of midpoint. Oh, there's a segment bisector or an angle bisector, so I have congruent angles or congruent sides, etc. We didn't get to talk about parallel in this video, but in your practice, there is some parallel. So, good luck, and that is it.